Alright, so we're moving on to Module B. Module B is going to be the discussion of polynomials. Before we get started with it, we just want to review our rules of exponents. This comes from section 1.4 of your textbook. Okay, so let's go ahead and review some rules of exponents. The first one we have is the product rule. And the product rule says that when your bases are the same and you are multiplying them, you will add the exponents. We also have one that's similar called the quotient rule. And the quotient rule says when you are dividing numbers with the same base, you subtract the exponents. The next rule we have is the products to powers rule. If you are multiplying two numbers raised to an exponent, you can think of this as distributing the exponent. Everything inside the parentheses is going to be raised to the exponent. Similarly, for quotients, if you have a fraction raised to an exponent, same thing, you distribute the exponent to everything inside the parentheses. And the last one we have is the power rule. If you raise an exponent to another exponent, you multiply the exponents. All right, so let's go ahead and look at a couple of examples. Example A, we have m to the 5th times m to the 7th. So we are multiplying two things with the same base. So we are going to keep the base and we are going to add the exponents. We should get m to the 12th. If we come down to example B, this is just a extension of it. The first thing we want to do is we want to multiply our numbers. Note we only add exponents. If there are numbers inside, or we're multiplying numbers, we still multiply the numbers. We get 5 times 3 is 15. We can combine our a's. They have the same base. If we combine them, we add the exponents. We get a to the 6th. And similarly for our b's, we have the same base, so we can add our exponents and we get b to the 8th. Okay, so that's playing around with our product rule a little. Now let's go ahead and look at our quotient rule a little. So here we have r to the 9th over r cubed. We want to subtract our exponents. We get r to the 6th. Example D. Again, this is just an extension of the quotient rule. So the first thing we're going to do is we're going to work with our numbers. 10 divided by 2. These are not bases, these are just numbers. So we divide, we get 5. If we combine our x's, we subtract the exponents, we get x to the 7th. And if we combine our y's, we subtract our exponents and we get y squared. Okay, let's go ahead and play around with our power rule now. Remember, when we raise exponents to other exponents, we multiply. So for instance, this one here, we're going to get 3, and 5 times 4 is 20. Now for example F and G, I'm going to use my product to power rule. And when you're doing your homework, make sure that you pay attention to what it wants. Does it want you to simplify, or does it want you to write in exponential notation? For f and g, I'm going to go ahead and simplify So if I go ahead and start by distributing my exponent, I get negative 2 cubed times x cubed is just x cubed. I do want to simplify the number part of this. Negative 2 cubed, well, 2 cubed is 8. We have an odd number of negatives, so this is going to be negative 8. And we bring down our x cubed. All right, let's do the same thing with a quotient. I want to distribute my outside exponent inside, and I also want to multiply my exponents for the x. So I get x to the 2 times 3 is 6 over 4 cubed. And again, let's simplify the number. We get x to the 6th over 4 times 4 is 16 times 4 is 64. Okay, so let's go ahead and continue with some other ones. The next one that we want to talk about is 0 as an exponent. And 0, anything raised to the 0 power, is equal to 1. So let's go ahead and look at some examples. 5 to the 0, this is 1. If we have the next two that we're going to look at, we want to be careful about whether the negative is inside the parentheses or outside. And so if it is inside the parentheses, the exponent is acting on it. So for instance, negative 5 raised to the 0 power is 1 as well. Now for example C, we do want to be careful. The negative is not inside the parentheses. Essentially what this boils down to is this is negative 1 times 5 to the 0. The 0 is acting only on the 5, not on the negative. And so if we go ahead and simplify this, this is negative 1 times 1, or just negative 1. So just remember that rule. If the negative is not inside the parentheses, let me go ahead and write it out so we remember it. If the negative is not inside the parentheses, the result will be negative. All right, the last thing we want to look at is negative exponents. And there's lots of rules in terms of negative exponents. The first one, or the first two that we have here, is b to the negative 1 is equal to 1 over b. We also have b to the negative n is equal to 1 over b to the n. A over b raised to the negative 1 is equal to b over a. And similarly, a over b to the negative n is equal to b to the n over a to the n. So negative exponents mean reciprocal. And reciprocal means flip it. So if it's in the denominator, or if it's in the numerator, it goes to the denominator. If it's in the denominator, it goes to the numerator. We do have one other rule. Remember that we had our quotient rule. Instead of doing b to the m minus n, you can also do 1 over b to the n minus m. We're going to see some examples of this. When we work with negative exponents, we always like to write our answer with positive exponents. And so this is something that you can use to kind of just take a shortcut, and we'll see an example of this soon. All right, so let's go ahead and jump into some examples. All right, so when I work with negative exponents, I try to do more than the required number of steps. I try not to combine steps. So for instance, 7 to the negative 2 this is the same thing as 1 over 7 squared. And then now I can go ahead and square my 7. We get 1 over 49. Let's go ahead and look at some negative numbers and negative exponents. If we go ahead and look at example B, this is 1 over, I'm going to keep my negative 7 inside the parentheses. We're going to square it. So for this one, we also get 1 over 49. Now for example C, again, remember that this negative is not inside the parentheses. So this is actually equal to negative 1 over 7 squared, or negative 1 over 49. Note that it's going to stay negative, just like I said on the last slide. Okay, now let's look at example D and see what we can do with this. Now, if it's in the numerator, we move it to the denominator. Note that if it's just a whole number, it's implied to be over 1. So when we look at something like D, if it's in the denominator, I want to move it up to the numerator. As soon as I move it to the numerator, or just make it a 6, I can change my exponent to a positive, and 6 squared is equal to 36. All right, let's go ahead and look at example E. Again, anything we want to write with positive exponents. So anything with a negative exponent, we want to move it. So 5, does it have a positive exponent? Yes, it does. So I'm going to leave it where it is. X to the negative 4, this has a negative exponent, so I want to move it down to the bottom. And y cubed has a positive exponent, so I'm going to leave it on the top. So our final answer is going to be 5y cubed over x to the 4th. Now, our rules that I mentioned on the previous slide, our product rule and our quotient rule, and all of those still apply. So for instance, if we look at 7 to the negative 3 times 7 to the 8th, I still want to add my exponents. And now it just becomes, do you know how to add signed numbers? If we add negative 3 and 8, we end up with 5. So this is equal to 7 to the 5th. Now example G, there's lots of ways to do this problem, and I'm going to show you a couple of them. One of the first things that we can do is we can just go ahead and use our quotient rule. I can rewrite this as -5 minus -4 becomes +4. This is b to the -1. And now I want to go ahead and write that with a positive exponent. So this is going to be 1 over b. Another thing that I can do is, if you don't like working with negative numbers, the first thing we can do is we can rewrite with positive exponents. So I'm going to move my b to the -4 to the top, move my b to the -5 to the bottom, and change the sign of my exponent. So I get b to the 4th over b to the 5th. Again, we can use our quotient rule. We get b to the 4 minus 5. This is b to the -1, or again, we get 1 over b. Now remember, we do have a second quotient rule. And the trick behind it is, which one do you want to move? So notice here, if I move 5 up to the top, I end up with a negative exponent, and I have to take the reciprocal at some point. Well, what we can do instead is, instead of moving 5 to the top, I can move 4 to the bottom. And again, I want to change my sign, so I get b to the 5 minus 4. 5 minus 4 is 1, or just 1 over b. So note, there are lots of ways to do these problems when you have negative exponents involved. Okay, let's go ahead and look at a couple other examples. Example H, we want to use our power rule. We're going to multiply our exponents. We get y to the -35. And again, remember to write with a positive exponent. I'm going to move it down to the denominator and change my exponent to a positive. Another thing that you can do on this problem is you can go ahead and move y to the -5 to the bottom to begin with. And if we raise it to the 7th power, again we get the same thing. 1 to the 7th is 1. And if we multiply our exponents, we get y to the 35. Now you could do this on I, but it's going to be kind of pointless. If we go ahead and just multiply our exponents, what happens when we multiply two negatives? We get a positive, so we just get a to the 21st. All right, let's look at example J. Example J, the first thing I'm going to do is I'm going to rewrite with positive exponents inside my parentheses. Again, there's lots of ways to do this, but for those of you that struggle with negatives, let's go ahead and just put our y in the denominator. Now when I have an outside exponent of a negative number, I do that in 2 steps as well. The first thing I'm going to do is I'm going to reciprocate the inside. So I get y over negative 3x to the fifth. And since I took the reciprocal, my outside exponent is now positive. And now I can go ahead and distribute my exponent. So everything to the fourth power, we get y to the fourth, negative 3 to the fourth. 3 to the fourth is 81. My negative is inside the parentheses, and remember, when you have an even number of negatives, your result is positive. So this is going to be positive 81. And for my x, I get 5 times 4 is 20. And we're done. All right, let's try another one like that. Let's look at example K. Again, the first thing that I'm going to do is I'm going to take the reciprocal of the inside, and I'm going to change my outside exponent to a positive. From there, I can distribute my cube to everything inside the parentheses. 5 cubed, you should get 125. We multiply our exponents, so we get y to the 2 times 3 is 6, and z to the 3 times 3 is 9. And I don't know why I have parentheses. We don't need them because this is our final answer. All right, last problem. So this problem, all we want to do is move anything that has negative exponents. So negative 5 squared, does that have a negative exponent? The answer is no. It stays on top. My negative is not inside parentheses, so the exponent is not acting on it. It is acting on just the 5. So we get negative 25. All right, x to the negative 2. That's a negative exponent, so I'm going to move it to the bottom. Y to the negative 5. That has a negative exponent. I'm going to move it to the bottom. Z to the 4th. This does not have a negative exponent, so I leave it on the bottom. And w to the negative 3 has a negative exponent, so I'm going to move it to the top. We end up with negative 25 w cubed over x squared, y to the 5th, z to the 4th. All right, that takes care of our review on exponents. You should be able to go ahead and complete the homework now. The next thing we're going to be talking about is we will be getting into polynomials and our different operations with polynomials. This is going to be I don't consider it a difficult module, but we are going to be combining our multiplying polynomials, adding polynomials, and we are going to get into the fun one, which is factoring. We'll see that in the next couple weeks. But definitely if you have your 114 notes, bring them out because you will need them for most of this module. All right, that takes care of this section. Go ahead and do your homework, and I will see you guys again shortly.